So welcome all again. Once 40 minutes got over, it gets disconnected. So we were explaining the concept of Bourdon tube pressure gauge. So I was telling about the input pressure signal which will be sensed by the Bourdon tube here. So this will act as a transducer stage 1. So the displacement in the Bourdon tube will be then modified in the transmitter in the transducer stage 2, which is nothing but the mechanical links and gearing mechanism. So through these, the deviation in the movement will be shown by the pointer and the scale here. So this is the gear intermediate stage. So with respect to the movement of this, the pointer will be showing the reading in the scale, what is the deviation it has been moving. So it will provide you the reading in the terminating stage directly. It is displaying you the reading. So you can read what is the deviation or what is the displacement of the Bourdon tube. So mechanical transducers are nothing but converting the physical quantity into the required displacement. So it shows the reading on the pointer what is the displacement of the Bourdon tube based on the received pressure as an input signal. So this is about the working of an Bourdon tube gauge. So this is about the Bourdon tube pressure gauge. So next comes the diaphragms. So this is the second type of physical elements which are used for in order to get the required displacement with pressure as an input signal. So how does the diaphragm looks like? So there are three type of diaphragms here. One is the flat diaphragm, one is the corrugated diaphragm, and the third one is the metallic capsule. So these are the three types of diaphragms in mechanical transducer which mainly use pressure as an input signal, right? So here the diaphragms basically are the elastic elements so that they can deform with respect to the received primary pressure input signals. So what happens here? Elastic diaphragms are used as primary pressure transducers in many of the dynamic pressure measuring devices. So this could be either flat or corrugated as shown in the figure. As I told you here, this is the diaphragm which is flat, and here the diaphragm is not flat, it is corrugated, right? So if it is in the form of a capsule, you call it as a metallic capsule. It is just corrugated here, so you call this as a corrugated diaphragm. But all these elements will be elastic bodies in nature. Okay, so a diaphragm, what do you mean by a diaphragm? It is a thin flat plate of a circular shape fixed around its circumference. Diaphragm, you know, every human body has a diaphragm in between, in the body below your digestive system. So depending, even during inhaling and exhaling the air, the diaphragm can move in and above, right? So which is associated in the stomach part of a human body. The application of it and the working principle is almost similar in case of mechanical transducers in diaphragm type of thing. Okay, so you can understand the same concept, which is a thin flat plate of circular shape fixed around its circumference. Okay, so when a differential pressure occurs across the diaphragm, it will deflect, right? So you have here the flat diaphragm. So this is the flat diaphragm, right? So in the flat diaphragm, you have the pressure variation. So you have the pressure which will be provided here, an input pressure, and you will be having the variation in the pressure. So when it is being subjected in both the place. So one input pressure in one way and the input pressure in the other way. So due to the deviation, due to the variation in the pressure, the diaphragm gets deflected in case of flat diagram. Okay, the same thing occurs in case of corrugated diagram or corrugated diaphragm also. So that is one being told. So when there is a differential pressure across the diaphragm, it will deflect. So the deflection may be sensed by an appropriate displacement transducer. So if you connect the diaphragm to an transducer like in strain gauge, I told you strain gauge is an example for pressure sensing device. So it senses the pressure and shows the displacement as per the received variation in the pressure. So a flat diagram is often used in conjunction with electrical secondary transducers whose sensitivity permits small diaphragm deflections. So wherever you need small diaphragm deflection, means the small variation in the displacement, it's always better to go with strain gauges in conjunction with the flat diaphragm, so that it helps in converting the required electrical secondary transducers to get the small deflections of the diaphragm. So this is about the flat diaphragm. So then comes with respect to the corrugated diaphragm. What happens in case of corrugated diaphragm? So when you need large deflections, then it shows the output signal in the form of large displacement. So wherever there is a need for large displacement, you won't go with the flat diaphragm, but you go with the corrugated type of diaphragm. So where it senses the variation in the pressure and it will provide you the deflection in the form of displacement. So there will be much variation in the pressure, so you will get a large deflection in the form of output in the intermediate stage where you can measure the displacement deviation. So this is about the corrugated diaphragm. Okay, even in case of metallic capsule also the working principle will be the same. So you will be having the variation in the pressure. So due to this variation, the pressure variation will be sensed and it will be modified in the intermediate stage, which will show the deflection, and that deflection will be converted into a readable form in the form of recording the displacement value. Both will be helpful in getting more deflection. Only the flat diagram will be associated to sense the small amount of deflection. So this is about the diaphragm and its classifications, and these are also under mechanical transducers only. But these are based on pressure sensing and providing the required displacement. And the third type of mechanical transducer under pressure sensing elements are bellow. So what do you mean by bellow? These are usually called as metallic bellow. So the metallic bellows are thin walled tubes, okay, which are formed by hydraulic presses into an corrugated shape as shown in the figure. So the entire unit, the body of the bellow is designed in such a way that it is in corrugated shape. Okay. So what happens if it is having a corrugated shape? So it helps in sensing the required pressure and showing large amount of deflection, because the entire body associated here is related to corrugated shape. Okay, so the bellows can be of diameter up to 300 mm. So the constraints for bellow specification is the diameter can be maximum until 300 mm, and these are made up of brass, which has a combination of 80% of copper and 20% zinc, and it could be also made by phosphor bronze, yeah, stainless steel, yeah, beryllium copper. So main thing what you have to understand is a differential pressure causes displacement of the bellows, which may be converted into an electrical signal. So until now the diaphragms and the Bourdon tube was able to show the displacements by the sensed pressure as an input signal, but whereas in case of bellows the sense pressure input signal could be converted into the required deflection and finally get the output signals in the form of electrical signal. So this is the main application of using bellow. So if you need an electrical signal, you are suggested to go with bellow. So if you are restricted only to get the displacement data with respect to the variation in the pressure at the input signal. So you can go up with either the diaphragm. So in diaphragm also again you have constraints whether you need only very low deflection or major deflection, right? Based on that again you have different type of categories. So depending upon one's application, the people can go for any type of physical elements in mechanical transducer. So that could be the spiral spring, the diaphragm, or the bellows. This is about the diaphragms. Okay, so in the next class I will be starting with the electrical transducer elements, because currently we have the seminars of the students of the final year, so it will start by 9:30, so I have to leave at least 5 minutes early. So for that case I'll be stopping the class right away. I can see now only the 27 students. Where are the others? So attendance to be given only for the 27 students who are there until the end, right? Fine. In the tomorrow's class, we will start up with the electrical transducers. So currently I am winding out. I'll just take the screenshot again. Yes, if you people have any doubt, you're free to speak a minute or so. Is it understandable related to the transducers? Hello, you people are here?
Yes, ma'am.
Yeah. So hopefully, hope you understand the concept of transducers, its classifications, the types and all until mechanical part what we dealt.
Yes, ma'am.
Yeah. Yeah, Tarun and others, please have a safe day. Go with all the classes successfully. Submit the assignments on time. So I will keep in touch with you all tomorrow morning. Hopefully after break I have, right? By 11:50. Okay. So until then, take care. Bye bye.
Bye.
Yeah, yeah. Bye.